As with any revolutionary technology that challenges our fundamental understanding of physics, space-time folding through 128-dimensional wave computing naturally faces skepticism from the scientific community. Here are straightforward answers to the most common questions. Doesn't this violate Einstein's theory of relativity? No, Einstein's relativity prohibits matter from traveling through normal space-time faster than light, but it doesn't prohibit shortcuts through space-time. This is similar to how general relativity already allows for the theoretical existence of wormholes. We're not breaking the cosmic speed limit, we're reducing the distance that needs to be traveled. Where's the experimental evidence for these extra dimensions? Traditional physics experiments have searched for extra dimensions at the quantum scale, 10 to the negative 35th meters. Our approach is fundamentally different. We access these dimensions not through high-energy particle collisions, but through coherent quantum field manipulations using C-space mathematics. The first experimental evidence came in 2023 with the detection of dimensional resonance patterns that couldn't be explained by standard four-dimensional physics. How can you possibly generate the energy required? Traditional wormhole or Alcubierre drive concepts would indeed require vast amounts of energy. The required energy will be harvested using millions of 7-watt ZPE nodes. Our approach is much more efficient because we're not warping space-time against its natural tendencies. We're finding and exploiting pre-existing dimensional structures. This reduces energy requirements by approximately 10 to the power of 8 times compared to traditional approaches, bringing them within practical engineering limits. If these extra dimensions exist, why hasn't anyone detected them before? They weren't detectable with previous technology and mathematical frameworks. It's similar to how radio waves existed throughout human history but weren't detected until we developed the right equipment. The breakthrough came when we stopped looking for extra dimensions as tiny, curled-up spaces, as in string theory, and instead recognized them as alternate geometric projections of existing fields. What about the exotic matter requirement for traversable wormholes? Traditional wormholes would require exotic matter with negative energy density. Our approach uses a different mathematical pathway that bypasses this requirement. We still need trace amounts of special materials to stabilize the fold interfaces, but at quantities thousands of times smaller than traditional approaches would need, and without requiring negative energy densities. Wouldn't this create causality paradoxes if you could travel back in time? Our current implementations strictly maintain temporal alignment. The entry and exit points remain synchronized in time. More importantly, even our theoretical work on temporal folding shows that nature appears to enforce what we call causality preservation constraints that prevent the creation of closed, time-like curves that would allow for traditional paradoxes. What about the enormous tidal forces that would tear apart anything crossing such a fold? This was indeed one of the greatest challenges. The breakthrough came with the development of the bridge operation, which creates a geodesically complete pathway that distributes tidal forces across higher dimensions, reducing them to levels that physical matter can withstand without damage. If this is possible, why hasn't advanced alien life already used this to visit Earth? There are several possibilities. One, they have, but interaction has been limited or undetected. Two, the technology, while theoretically accessible to any advanced civilization, requires very specific insights that may not be obvious evolutionary developments. Three, interstellar civilizations might exist in a state that doesn't require or desire physical visitation. Four, we might simply be among the first technological civilizations in our region of the galaxy. How can you be confident about the safety of manipulating space-time this way? Safety has been our paramount concern. Unlike more speculative approaches, our technology includes multiple fail-safe systems. Most importantly, the mathematics shows that space-time folding is inherently self-limiting. Attempts to create dangerous configurations cause rapid energy dissipation rather than catastrophic effects. We've also implemented dimensional isolation protocols to prevent unintended consequences. While healthy skepticism is valuable in science, it's worth remembering that many transformative technologies, from heavier-than-air flight to quantum computing, faced similar skepticism before their practical demonstration. At McGinty AI, we welcome rigorous critique as we continue to advance this technology with appropriate caution and transparent scientific methodology.